Okay, let's start. Assalamualaikum warahmatullahi wabarakatuh. Uh, Good evening. It's evening here, and I'm sorry for a lot of noisy voice around me because it is really crowded here. And mainly, I'm sorry because I uploaded the video really late. No, I was supposed to do that. Sorry, I forgot. I almost forgot to do this. So, uh, let's just start. I will like to explain in this video on why do airplanes have swept wings. Okay, so this presentation is presented to fulfill my English assignment to my teacher listening. I hope you watch this hopefully. And yeah, let's just start. So, modern aircraft typically does have swept wings. For example, you can see this Lufthansa, this is Boeing 747, and this is Airbus A380. Like, this is our two major producers in aircraft, commercial aircraft. Typically, you can see all of the Boeing and Airbus aircraft today have swept wings. And that so I will try to explain my best on how why do aircraft have swept wings, why do engineers choose this configuration to design some aircraft, and why does some of them doesn't have this configuration. For example, you can see this is an ATR. We have around 100 units of this in Indonesia, and this is N250 Gatot Kaca, which is I'm really proud of this. This is one of Indonesian masterpiece, and this is N219 that are also produced by Indonesian aerospace industry. They don't have a sub things. You can see it like this is their wing are really straight like this. And if you go back here, you can see they have a really different configuration. Like why do they have this and why do this doesn't? So what is happening when an aircraft and solid aircraft moving through the air? So caused by the shape, by the really well designed shape of aircraft wing, they will generate a pressure gradient. And you can see this. Like one of the features that are given by this curved shape of an airfoil. Airfoil is basically a shape of aircraft wing. You can see this is an airfoil and airfoil, just the same thing. They are a wing profile. On you can see a lot of type of it. Like there are some supercritical airfoil, there are low speed airfoil, they are cambered, they are symmetrical airfoil, and so much. But mainly this curve shape. Mainly airfoil have this curve shape. And why do they do to the aircraft? How the aircraft generates lift from it? So this curve shape generates a pressure differentiation. I can say that easily. I really hope that you understand it before you watch this video, or I will recommend you guys to watch this video. They are explained by Professor Holger Verbinski. It's really good if you want to understand about why do aircraft generates lift, how do they fly, and so one of the features of this curved shape of the aircraft is they could accelerate the airspeed. So the relative when they are moving in the aircraft could be accelerated caused by this shape. You can see this, and you can see that they are accelerated. So it means that we can easily say it is logic to say that if we fly, for example, at 100 miles an hour in aircraft, there will be some part of the wing that having an airspeed that experience an airspeed of more than 100 miles an hour, probably maybe 120 miles an hour or 130 miles an hour. And so let's look back at this this picture. We need to really look precisely on this. So you can see here that the normal velocity like this. So the red ones are really high speed velocities, are really high speed air moving here. Here you can see that this this is, let's say that you are moving on 100 miles an hour, so there's a pattern. This part will experience maybe 130 miles an hour, but they will come back. They will be slower, 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 and decelerating through this part. So you can see that the speed is not as much as high as here again when the air is travel through the chord line of the wing. Let's say that if we fly at, for example, Mach 0.6, it will be possible, according to the picture that we've learned before it, that there is some part of the wing that will experience maybe Mach 0.8 or more. So therefore, if we fly, for example, at Mach 0.8, it is possible that there will be some part of the aircraft wing that experience a speed of supersonic or exceeding Mach 1. And what will happen? What will happen if we exceed Mach 1? So, oh, there is another term that I need to explain to you. So there is a term that called critical Mach number. So critical Mach number is the speed that which there is shockwave firstly formed on the aircraft. We call it a critical Mach number. So if at Mach 0.8 there's suddenly a shockwave form, or there's suddenly some part of the wing that experience Mach 1, minimum Mach 1, so you can say that Mach 0.8 is the critical Mach number for your aircraft or for your wing. The airspeed is subsonic and increase to supersonic, and they decrease again to subsonic. So basically, the most simple explanation is there's some particle of the wind that are here, moving here, and already decelerated, moving fast and decelerated. You can say that this transition between high speed and low speed will create a shockwave. And what shockwave could affect on aircraft? So shockwave will affect on mainly the flow separation over the wing. Flow will be easily separated, and if the flow is easily separated, you will get. I really hope that you understand lift first. So the lift will be decreased, okay, and the drag will be increased, and therefore the moment will change in aircraft. And you can say that if the moment are changed, there will be some instability, like the aircraft will not be stable. And if you're not stable, there's no one who like to fly in aircraft that are jiggling like this. Or okay, so I will emphasize that shockwave could cause a bad impact on aircraft control. And okay, so let's dive into wing sweep. So here it is actually a really simple term of trigonometry and vector. You can see this is a straight wing. So let's say that we are flying in straight wing, and assume that the Mach critical for this wing are 0.7. It means that in Mach 0.7 you will experience a shockwave here. We can say that here, actually, the air is moving like this. Sorry. Here, like this is the aircraft flow moving. But you can divide it like another vectors in this. You can divide it to this component and this component. Like it is flowing like this. You can divide it to this vector component, this vector component. This is the one that are parallel to the leading edge, and this is the one that are parallel to the chord line. I'll explain about chord line later. So the most thing that you need to know is this part, this component of vector doesn't impact anything to the acceleration. So you can really neglect it. Like it has an impact, but they're really small. You can say that airflow sees only this component of velocity. So the one that will be accelerated like this, that will be accelerated like this, or like this, is only this velocity component, this air velocity component that are perpendicular to the leading edge or parallel to the chord line. Chord line is from leading edge to trailing edge of the wing. So the airspeed could be divided by the factor of cosinus of the sweep angle. You can see this is the sweep angle that this is the angle that we define as the sweep angle. So like this is vectors. I really hope that you understand this. I'm sorry. I don't think I can explain it really clear here. So that is the most simple explanation. Why do you sweep the wings? Because you want to divide the factors, the velocity factors. Because the one that we only accelerated is this. So for example, if you have a critical Mach number of 0.7 in this straight wing, a really same wing, but you just sweep it. You just have to give them a sweep angle of 30 degrees. It will be the Mach, the critical Mach number will be uh, affected by the factor of cos 30. You can see this. The Mach number is increased. You see that? So the critical Mach number is increased, but the real velocity of the air here are decreased. Okay, so in with this difference of wing and the same speed that you reach with your aircraft engines, for example Mach 0.7, you will experience a supersonic wave on this, so you will experience shock wave on this type of thing. But here you will not yet experience that. It will be increased like the critical Mach number to cut supersonic speed flowing through your aircraft will be increased. So the velocity here will not exceed the speed of sound yet. So you can fly, it means that you can fly faster. So that is the whole of the thing means. You can fly faster. So, for example, in this wing, if you exceed Mach 0.7, there will be some problem happen to the aircraft. But if you have this kind of wing type, if you fly at Mach 0.7, there will be nothing happens yet. But if you fly at 0.8, for example, that will be that that is where the problem will start to happen. So, for this kind of aircraft, can like this kind of aircraft, these Airbus or Boeing that are having turbocharged engine and really big, they fly really fast. Like if you the speed is really high, like 700 kilometers an hour, 800, or even some of them are 900 kilometers an hour. But it is still less than supersonic, and the aircraft are trying to maintain that there is no any shockwave formed in the wing. So this actually has a consequences by making the airspeed less on the aircraft airfoil, so the lift will also be decreased. The lift will also be decreased. And there is a minimum speed that will allow your airplanes to float on the air. So that minimum speed will increase if you sweep the wing. So that is the reason why too the aircraft that are not flying near the sound barrier or near the speed of sound, they don't use the sweeping configuration because it will not help them anything. It won't help anything to them. It will just reduce the lift. So another alternative way is to design an airfoil that you call a supercritical airfoil. You can see this, like they prevent this depression and they make the shockwave much more weaker on the aircraft. That's one of other ways to prevent shockwave. I'm really sorry if you don't understand. I want to explain it. If there is anyone who will understand this video. But thank you for watching, and yeah, I'm really happy to make this. Bye.